What's happening? Everybody stay calm.
What's the procedure, everyone? What's the procedure?
Stay calm.
Wait.
Everybody just calm down.
Alrighty people, welcome back to the channel. Alright, this is the third time lucky. Hopefully we have audio this time. If we don't, that is mightily embarrassing. Alright, today's video is going to be about our practice test for our current topic, which is measurement. And boy, this is a doozy. I'm going to get into that, but before we do, we are going to give a quick shout out to today's sponsor, and that is Casio. If you need a calculator, Casio is the team for you. Look at these complex equations that we've got going on here. In the click of a button, Casio spit it out, and boy, do you know it's correct. If you need a calculator, Casio is your brand. So back to our video. With our first question, we're going to be looking at converting. So take note of the different units. So hectares to kilometers squared, centimeters squared to meters squared, meters to kilometers, meters to centimeters. What you will need to do is make sure that you are following the arrow the right way from meters to centimeters and looking at the equation at the top. Is it timesing by or is it dividing by? Just be thorough with that. I'm not going to answer those questions for you on the video. I think you are capable of doing that. Next one, we have determined the perimeter. Perimeter is the sum of all sides of our shapes. Okay, so we have a look at this one. We've got 12 meters, 17 meters, and we've got 8 meters over here. This little symbol here and here indicates that they are the same length. All right, we should know that, but just in case you forgot. All right, and we add them all together, and that gives us 45 meters. Question B, all right, we have a couple unknown sides here, and the way I got it to 4 is because this bottom side is 12, this top side's 8, so that indicates that that's got to be the difference between those two, which is 4. That line means that they're the same. How I got to 6, well, 4 and 2, that gives us 6. Add them all together, that gives us 36 meters, all right. Next question, determine the area for the following shapes. All right, we have a rectangle, which is just length times by width, 8 times by 6. That gives us 48 centimeters squared. Remember that now that we are using area, we are using our meters, centimeters, millimeters squared. So it's important that we remember that. Next one is our triangle. All right, 14 kilometers by 7 kilometers. All right, is the height of that 7 kilometers. We know that our formula is base times by height divided by 2. 7 times 14 divided by 2, it gives us 49 kilometers squared. That is that one done. All right, make sure as well for both we write in our formulas. All right, we need to show that we know the formula, we can replace our numbers, and we can find the answer. All right, determine the length of x for each of the following right-angled triangles. Right-angled, all right, x is our hypotenuse in this question. So that means we are using our formula of a squared plus b squared equals c squared. We're just going to replace c squared with x squared and replace our numbers there. We go in order. We show that what those numbers are squared. All right, that equals x squared. To get rid of that x squared, we're going to find the square root of that sum as well. That gives us 13.6 meters. The next one, all right, we have a squared plus b squared plus c squared. But this time we are not trying to find the hypotenuse. We've got to manipulate the formula a little bit, all right? So we know that x squared plus 7 squared equals 15 squared. We know that because of Pythagoras' theory, all right? So we move that around. Rather than adding 7 squared to x, we're going to take 7 squared from x, just so it cancels each other out. And what we do to one side, we have to do to the other. So it becomes 15 squared minus 7 squared equals x squared. We work out that sum, we square root it to cancel out x squared. That will leave us with x equaling 13.27 centimeters. Our next question, the dimensions of a dining room are shown below. 16,000 millimeters by 8,000 millimeters. Convert the dimensions dining room into meters. All right, so we have 16,000, dividing it by 10 to put it into centimeters, then dividing it by 100, all right, to put it into meters. Gives us 16 meters. Then we do the same with 8,000. That gives us 8 meters. That is a massive dining room. People, they're probably hosting some pretty fancy parties if you ask me. All right. Calculate the perimeter of the dining room in meters. Well, we just know it's 16 plus 16 plus 8 plus 8 equals 48. Why? Because we've got these dashes here. The two dashes show that those two sides are the same. The single dash shows that those two sides are the same. And that is that. Calculate the total cost of flooring if it is to be covered in vinyl. That costs $24.50 per square meter. That's really straightforward, this one, guys. It's 128 total meters squared times by 24.5. That gives us 3,136. That's the total cost to cover the flooring. Must be nice to have that sort of money to spend. All right, determine the perimeter of the following shapes. Now, the formula that we gave you in class was for that arc, all right? So that is this formula here. But because we need to add the two sides, the two slices of the pie, all right, we have 2 times r added on at the end. So our angle over 360, this is a right angle. We know that because of that square there. It means it's 90 over 360 times 2 pi r plus 2 times r. All right, we chuck that into our trusty Casio calculator and it would give us 28.57 meters. Next one. We are trying to determine the perimeter again, but we have this unknown value here. How are we going to work that out? Pythagoras' theory, all right? X squared equals 18 squared minus 8 squared. 324 minus 64. We find out the square root of that. It gives us 16.12. We add all those sides up. It gives us 42.12 meters, all right? And that is how we work that out. Centimeters, sorry, not meters. Next question, determine the volume of the shapes below. We've got a sphere, all right? We know that the volume of a sphere equals 4 over 3 times pi times r cubed, all right? It's to the power of 3, not to the power of 2. So we replace those numbers, and that is what we get, 998.31 centimeters cubed. All right, on to the next question. We have volume. Again, all right, this is a uniform cross-section. We have a prism. All right, we find out the area of this face and then we times it by the length. So we have a triangle, that's our formula for our triangle area, then we times it by the length. So we replace the numbers. Our length is 7.2, our height 6.2, and our width is, our base is 4.7. All right, times over 2, that gives us 104.90 centimeters cubed. Make sure we are putting it in centimeters cubed or meters cubed, whatever the unit is. Make sure you do it. If you don't, that will lose you a mark, and we do not want to lose marks here, people. Question number 8. Below is the garden, or is a garden with a shaded part being existing lawn. All right. The owner wishes to replace the lawn with artificial grass. Ooh, la-di-da. He must live in Burnside. All right. The area. Now, I split this into 2. The red is the circle. We have 2 semicircles, so we're going to join them together. All right. We know that the area of a circle is pi r squared. That could be turned into a catchy song. I don't know if someone's made that up yet, but maybe someone will. All right. 8 meters, we divide that by 2 to get us our radius. That's 4. So pi times 4 squared equals 50.27. Then for our whole rectangle, all right, we got length times by width, that gives us 120. To find out just the shaded area, we find the difference between 120 and 50.27, which gives us 69.73 meters squared. That is really straightforward, guys. All right, determine the cost of replacing the lawn if the artificial grass of the cost is $21.50 per meter squared. Artificial grass is cheaper than vinyl, apparently. That's interesting. All right, so we go 69.73. That's our total meters, and we times it by our cost, and it gives us this 1,499.195. Now, remember, we are rounding up to 2 decimal points because we are working in money. So it's $1,499.20. Make sure with these ones we write our final answer as $1. All right, value. If you do not, that will be losing a mark. Next one, the following diagram shows the width of an irregular shaped pond. Using Simpson's rule, determine the area of the pond to 1 decimal place. All right, let's just make note of that, okay, to 1 decimal place. If it says that in the question, make sure you follow that instruction. I did not. Whoops. Anyway, we know our formula for Simpson's rule. So it's width over 3 times our first length plus 4 times our second length 1 plus L2 end bracket. All right. Notice here, we have to use it multiple times, okay? We have a 0 factor here and we have a 0 factor here because there is no length, all right? So we replace the numbers. We got our width of 0.9 over 3. Make sure you are using the width between the different offsets, okay? Plus 0 So 0 plus 4 times 1.44, that's that first length, times 2 times 1.4 plus 4 times 1.5 plus 0 for that last offset. All right, that gives us 4.39 meters squared, but I didn't read the question, so it's 4.4 meters squared. How could you obtain a more accurate estimation of the pond? I'll leave that up to you. Have a think. We got some big brain ideas in the class, all right? We can do that one on our own. The pond is found to be 1.3 meters deep. Calculate the volume of the pond. Now, we've got to imagine that this is just going to be straight down. It's going to be like a pool, all right? It will have a uniform cross-section going down throughout it, all right? So we know the total area of that, and we times it by our depth, which is 1.3. That gives us 5.71 meters cubed. Determine the capacity of the pond. Okay, that's where it wants us to put it into like a unit of measurement for liquid, which is our milliliters, liters, megaliters, kiloliters. All right, so 5.71 meters cubed goes directly into 5.71 kiloliters. Okay, make sure you have that conversion chart on you in the test. All right. Question number 10. A tree casts a shadow of 7.7 meters when the angle of elevation to the sun is 42 degrees. All right. Using trigonometric ratios, find the height of the tree. First thing we've got to do, we've got to know what we've got. So we've got this angle here. We've got this measurement here, and we're trying to find this measurement here. If we ignore the tree, we've got a perfect right angle triangle. I've got our angle, we've got our adjacent, and we are trying to find our our opposite, All right. So that means one thing and one thing only. We are using our tan ratio. All right, so tan equals opposite over adjacent. We replace our numbers with our values. So tan 42 equals x over 7.7. To cancel this out and to isolate x on its own, we're timesing this side by 7.7. And what we do to one side, we have to do to the other. So it goes x equals tan 42 times 7.7. Gives us a 6.93 meter tall tree. That is that. Our last question for the day. So we have Jack and Robert. They play footy together at the same club, but Jack lives 4.8 kilometres away from the club and Robert lives 15 kilometres away from the club. Referring to the diagram above and using the cosine rule, determine how far away Jack and Robert live from each other. All right. We have our cosine formula. So that is a squared equals b squared plus c squared minus 2bc cosine a. All right. Remember, it doesn't matter what is B and C because they're just adding together and they're both squared and they're both timesing together here. All right. It doesn't matter which one you select for B and C. All right. We are trying to find A. Imagine this is A here, and that is our angle that we are given. So we write out our formula, replacing our numbers with we're replacing the letters with the numbers. And because we are using our very trusty Casio calculator today, look at that complex calculation that it's had to put in. All right, it spits out 17.03 kilometers. That is that video done. 12 minutes of the best. Just a very quick shout out to my good friend over at David Dobrik. I think that's how you pronounce it. He's starting up. He's getting pretty popular. Make sure you go over and check out his stuff. I'd like to know who I shouted out when you see me next in class so I can confirm that you watched this video. One final mention to our sponsor, Casio. Thank you for all your help today and all your help whenever we are in need of making calculations. Remember, if you need a calculator, Casio is your brand. Thank you.